I will be doing problem 9 on chapter 5 on pages 192 to 193. This is a diagram of the picture for the question, which includes a thermometer, stand, burner, test tube with water, and shield. Below is the data collected from this lab, which is the initial mass of burner, final mass of burner, mass of water, initial temperature of water, and the final temperature of water. We will be using this to answer the questions. The first question is, calculate the amount in mole of methanol burned. To start the problem, I wrote out the equation given. Then I flipped it backwards because it's products minus reactants. So first I found the entropies of the products, and then I minused it by the entropies of the reactants. The final answer came out to be 717.5 kilojoules mole to the -1 power. The second question is, calculate the heat absorbed in kilojoules by the water. To begin, I subtracted the initial mass of the burner methanol by the final mass of the burner methanol. So the initial mass of the burner methanol was 80.557 grams. The final mass of the burner was 80.034 grams. Which equals 0.0523 grams. Then I divided 0.523 grams by the number of the molar mass of the methanol, which was 32.04 grams per mole, which equal to 0.0163 moles. The third question is, calculate the heat absorbed in kilojoules by the water. To begin, I subtracted the final temperature of water by the initial temperature of water. The final temperature of water was 26.4 and the initial temperature of water was 21.5 Celsius. Both were Celsius, which equals to 4.9 Celsius. Now then I can begin to find the heat, which is mass times specific heat by change in temperature, which is 20 grams times 4.18 times 4.9 Celsius. I multiply all those numbers together and I got 409.64 joules. Converted to kilojoules is 0.41. The fourth question is, determine the enthalpy change in kilojoule moles to the -1 power for the combustion of 1 mole of methanol. To find the enthalpy change, we divide heat absorbed by the water by the mole methanol burned. The number for heat absorbed by the water was found in the last question, and the moles of methanol burned was found in the second question. So it would be 0.41 kilojoules divided by 0.163 moles, which would equal to 25.15 kilojoule moles to the -1 power. The last question is, the data booklet value for the entropy of combustion of methanol is -726 kilojoule moles to the -1 power. Suggest why this value differs from the values calculated in parts A and B. The reason why the values are different is because methanol is a liquid, not gas. The data booklet shows the entropy of methanol as a liquid, and the one in this question refers to it as a gas. So that's why the two values are different.